Hi, mathematicians. I'm sorry that I am not there for our first day together. I'm not feeling well. You can probably hear that my voice is a little scratchy. Not that you know what I actually sound like, but this is really kind of scratchy. So I am sorry that I am not there, but we are going to do the best we can with this. So hopefully you have the notes packet. And I don't know what I was doing here. Well, we want to go from general form to vertex form and vertex form to general form, all for this quadratic. And then we also want to go from this general form to intercept form, and I guess that's the factored form, and from intercept form to general form. So 2x squared, uh, 2x squared minus 8x minus 10. All right. So there's a couple of ways. I don't think you've seen completing the square, so I'm not going to do that. What I'm going to do is find the vertex with negative b over 2a and go negative 8 over 4, which is 8 over 4, which is 2. And 2x minus 2 squared. And then if I put in a 2, the answer is 8 minus 16 minus 10, which is negative 18. Now, if I want to go from this format, I don't know why I formed it, but back to that general form. This is really 2 times the quantity of that, so it looks like that. 2 times x squared minus 4x plus 4. 15. Distribute 2x squared minus 8x plus 8 minus 18. Oh my goodness, look at that. It is it. Ooh, and the crowd goes wild. I basically just ran in a big circle. Alright, and then this one, to go to intercept form, that's looking for this factor form. I'm going to pull a 2 out of everything because I like to do that, especially if it's possible. And there we go. There's that intercept form, or factored form, another name for it. Factored form is nice because then you can see the zeros from it in terms of graphing. I'm going to distribute the 2 first. It doesn't really matter. And then I'm going to double distribute or FOIL this. And hey, look, it came out as that same. So all this is really saying is that this version, and this version are all equivalent forms of the exact same problem. And similarly, the graph of all of them are the same. Okay? So we're going to work through this example together. We're going to complete the square in order to convert to something into vertex form. So if you notice on this one, I did my negative b over 2a and then plugged it in for the y value to get into that vertex form. Works! A little cumbersome. So I'm going to do this snazzy thing called completing the square with it. So what you do is you have y equals 2x squared minus 8x minus 10. So the problem I'm doing here is actually the same problem that we just did. So we know what the answer is going to be. Okay. So first thing I'm going to do is usually when you're solving by completing the square, this left-hand side is a 0. I'm not having a 0 in this problem because I'm not solving. I'm going to rewrite it. Now, some people move the 10 over. I tend not to do that. You just kind of push it over to the side and pretend like it's not there. Minus 10 x squared minus 4. Okay. Now, I need to add something into this spot to make this a perfect square trinomial. Notice I put a square. We're going to complete the square. We take that b, which happens to be negative 4. We divide it by 2 and then square it. So negative 2 squared, which is 4. Okay. But I really added 8 because see how I have that 2 factored out on the outside? So 2 times 4 really is 8. Now I can add the 8 to the left-hand side if I'd like. Some people will subtract it on the same side. that would be an alternate way of doing the same thing. Then I take this piece that I have here in blue and I factor it. It'll be easy. What am I doing? And I subtract the 8 on both sides, and y equals 2 x minus 2 y squared minus 18. So there are, and on yours it says pick 1 or 2, and then 3 or 4. So what I'm going to do is I want you to pick one of these two, pick 1 or 2, pause the video, and do one of those two problems. I don't care which of them you do, but pick either this one or this one. All right, you got one of those problems done? Okay, so now we're going to do the same kind of thing. I'm actually going to do number 3, and then I'm going to have you do number 4 independently. So here on number 3, we're going to do that same thing. You could use f of x instead of y. We can fit with that. If you want, you can move the 7 over. I'll show it on this time. Move the 7 over if you like that. And I'm going to pull the 2 out. Oh no! And I pull the 2 out this time. It's a 5. That's okay. We can still work with that. It's just a little messier. So when we divide by 2 and then square, we're going to get 25 fourths. Yes, leave it as 25 fourths. X squared plus 5x plus 25 fourths. And then I really added 25 halves because it was 2 times it. Okay, and this came from 2 times that. Then f of x, I'm going to combine these two. So what I have here is negative 14 halves, 5 halves is 11 halves. The reason I left this one as a fraction is because it's easier to factor them. And then f of x is equal to 2 times the quantity x plus 5 halves squared minus 11 halves. And now it didn't say to, but just as a reminder, our vertex here is opposite of this, comma this. So if I wanted to know where this graph was, her vertex is at negative 5 halves, comma negative 11 halves. And then it is opening up. It has a vertical stretch of 2. So if I was going to sketch it very, very roughly, 1, 2, 3, 4, 5, so 5.5 and 2.5, it would be like that, and then upwards. Okay, that's a very, very rough sketch. All right, so you try number 4 to convert to vertex form. Go ahead, pause the video. That's fine. Okay, did you do it? All right. Now what we're going to do is take a look at some maximization problems. So maximization problems are when you're trying to make the most amount of profit or find the maximum area and things like that. So the income from ticket sales for a concert is modeled by the function I of p is equal to negative 50p squared plus 6000p, where p is the price of a ticket. Calculate the maximum value of this function. In other words, how high does the income go? So, and what price should be charged in order to attain this maximum income? So we can do this one of 2 different ways. We can convert to vertex form and find the vertex that way, or we can do negative b over 2a. Doesn't make a difference which one you do. I think I'm going to kind of mix them up and do this one with that, mix up the different ways. So I'm going to do p is equal to negative b over 2a because it's going to find the input. This is my a, this is my b. So we're going to have negative 6,000 over 2 times negative 50. P is negative 6,000 over negative 100, which is 60. So the price would be $60. Now, to find the actual income that that's going to be, is we're going to do income of 60, and we're going to just plug it in. So basically, what I'm doing for these maximization problems is I'm finding the vertex, and one part of the coordinate is telling me the answer to one question. Like the x-coordinate is answering one part of the question, and the y-coordinate is answering another part of the question. Okay, this one happened to be A was the y-coordinate, B was the x-coordinate, but it could be either way. So, so 100 times 50. Oh, it's 160,000. And so I of 60 is going to be 180,000. So the maximum income that they're going to get is when you sell a ticket for $60, the income's going to be $180,000. A skating rink manager finds that the revenue R is based on an hourly fee for skating. Is represented by the function R equals negative 480 f squared plus 3,120 f. What hourly fee will produce the maximum revenue? Okay. So this is the fee. So this is looking for the x-coordinate of the vertex. Okay. So again, I could do negative b over 2a, and that's going to help me. 960. Yeah, 960. The max revenue is going to happen when they charge $3.25 per hour. Okay. If I wanted to do it by converting to vertex form, I'd have R equals, factor out that negative 480 x squared plus 6.5 square. See how this is longer? But nice to tie into what you were doing. Plus, and plus it. R equals negative 480 no, at least I caught it. So then here, that's that. The price should be this. Now this question didn't ask it, but this will be the maximum revenue. I personally see this particular problem like this. But to tie back to, again, what we were just doing. All right, so here we have two more. A company knows that negative 2.5p plus 500 models the number it sells per month of a certain unicycle, where p is the price, can be set as low as 70 or as high as 120. Okay? Revenue from the sales of the product is the product times the number sold. R equals p times negative 2.5p plus 500. what price will maximize the revenue? What is the maximum revenue? So this one's given to us in factored form or intercept form. And you can see our intercepts are going to happen at 0, which we wouldn't want to be finding these. So what these are really finding, if I set these equal to 0, because I know somebody is tempted to do it, these are telling me what price will give me no one buying it. Okay. So basically, if I were to sketch the graph at 0, if I set my price at 0, I make no money. Well, yeah. If I set my price at 200, I will also make no money. And the reason I will make no money is because no one will want to spend $200 on a unicycle. Okay. And somewhere in between is the max. The max happens to be, if these are my two intercepts, because it's a quadratic, the max has to be directly in between them. So directly in between them is 100. Notice I didn't even use negative b over 2a. What? Is that even allowed? Yes. I can use lots of different methods to find these, which I think is a wonderful thing. The maximum revenue is running out of space. Didn't space it well. Okay. So 100 times 500. So the revenue. So if I sell my unicycles for 100 apiece, the revenue will be 25,000. Okay. Now, could I have distributed? I said R equals negative 2.5 p squared plus 500 p. Oh, and then p equals b over 2a negative 500 over 2 times negative 2.5. I got negative 500 over negative 5, which is 100. I got the exact same thing. So I'm not saying that negative b over 2a is a bad way to go. I am saying that we can do this multiple ways. And depending on what format, tie back to that do now, general form, negative b over 2a is awesome. Vertex form, read the vertex off of it. Intercept form, find the average of those intercepts. Having that flexibility to use the method that makes sense for that problem is a really cool thing. And I think that's something awesome about math. All right, a rectangle has dimensions of w by 260 minus w in feet. Oh, I'm going to draw the rectangle. So this is w by 260 minus w. What width will maximize the area? What is the maximum area? So now we don't actually even have an equation here, but we can find the equation. The area of this problem is going to be length times width. So width times 260 minus w. And a couple options. I could, since I'm in a factored form, I could find those roots and then find the hill in between them. But let's do negative b over 2a because I was kind of mean to it on the last problem. One thing to keep in mind if you're doing negative b over 2a, you want to make sure you're in power descending order because otherwise you might mislabel your a's and b's. So my width is going to be negative b over 2a, which is going to be negative 260 over 2 times negative 1. Negative 260 over negative 2, or 130. So this side is 130. This side is 130 also because it's 260 minus 130. So the max dimensions, the width is 130 feet, but it's actually all square. It's 130 feet by 130 feet, or square of the area. Huh? So our first type of word problems have been these maximizations. So on any of these maximization problems, I have these quadratics that are opening downward, and we're finding where this hill is, and that's to maximize profit or income that comes in from things. I'm maximizing the revenue, or here I'm maximizing the area in a rectangle, which happened to be a square. We can also minimize things. If I'm doing a minimization problem, that means I have my problem is opening upwards instead, and I'm trying to find where that valley is. For these minimization problems, I'm still going to use the same idea. I can either use negative b over 2a as one strategy. I can convert to vertex form if I feel so inclined. Or I can do the average of those x-intercepts to find the all those help me find the x value for that vertex. So minimization. A lighting fixture manufacturer has a daily production cost of 0.25 n squared minus 10n plus 800, where C, the n, is the total cost daily in dollars, and n is the number of light fixtures produced. How many fixtures should be produced to yield a minimum cost? So I want to figure out how many I need to make in order to minimize the cost for this. This time I'm going to use so n is equal to b over 2a. What am I doing? Over 2a. So negative 10 okay, over 2 times 0.25. So I have positive 10 over 0.5, which will be 20. So this is 20 light fixtures for that minimum. The equation for cost in dollars of producing automobile tires is C is equal to that, where X is the number of tires produced. Find the number of tires that minimizes the cost. What is the cost for that number of tires? Again, I'm going to do negative B over 2A. Negative 0.03 over 0.004. 1, 2, 3, 4, 1, 5. And this is going to tell me the number of tires. And then in order to find out how many or how much that cost is, we are going to plug it back into the function. Times 2. So positive 0.03, 0.03, so 300. It's going to be 1,000. We're talking about 1,000 tires. And then when we plug that in, it's $20 of cost. So apparently, producing 1,000 tires is going to cost $20. Or yeah. Ooh. So next one. Find two numbers with a difference of 10 and a product that is the minimum. Interesting. So if the two numbers have a difference of 10, that means x minus y is equal to 10. X is 10 plus y. And the product of them is going to be x times y over y times y. I'll use this problem in terms of y. That's fine. X times y and 10 plus y times y. So I want to minimize this. Okay? This is y squared plus 10y. And I'm going to do negative b over 2y. Negative 10 over 2 times 1. And I get y is equal to 4. So if that's 5, we're going to have x equals 10 minus 5. So x is 5. So my two numbers are 5 and negative 5. That's product will be the smallest. So the product there is, negative 25. A baker has modeled the monthly operating cost for making wedding cakes by a function where y is the total cost in dollars and x is the number of cakes prepared. How many cakes should be prepared to yield the minimum operating cost? Show your work and give me an answer. So I'm going to do negative b over 2x, negative 12 over 2 times 1 half. And give me the x is the minimum. We have 12 over 1. And so 12 cakes is the minimum. All right, now the next style problem is when you find roots in 0. Okay, so if on the last one we could have parabolas going either opening down or opening up on this type, what we're looking for on our answer is where we're hitting the x-axis. And so you'll see that in the word problems because you're either going to be finding when something's hitting the ground, or when we want something to be equaling 0, or we know that it has to equal something in particular for a value. Suppose you throw a ball straight up from the ground at a velocity of 80 feet per second. The ball moves upward and gravity slows it. Eventually, the ball begins to fall back down to the ground. The height h of the ball after t seconds in the air is given by the quadratic function negative 16t squared plus 80t. If I factor this, it's equal to 0. I can factor in a negative 16 and let the t minus 5. And so t is equal to 0 or t is equal to 5. All this in 5 seconds. Because this is that starting value. So what's happening, I'm starting at 0 and after 5 seconds. Okay. So how many seconds in the ball air before it hits the ground? Boom. Done. 5 seconds. Other questions, though, that could have been asked from this. So this is only asking this, when does it hit the ground? But it could also ask what was the highest value that it reached. And that would be a maximization problem. So don't just assume that all velocity problems are always going to be looking for these roots. This one happens to be. But you want to make sure that you're reading it carefully, because I could ask a maximization problem on this for how high does it actually go. A ball thrown in the air and its height is represented by this equation, where t is the time in seconds and h is the height in meters. After how many seconds does the ball ground? Then write your answer in a complete sentence using the context. Okay, so we're in meters this time. That's why I've got that negative 5. Well, that's rounded. Okay, so I want to see how this is going to affect. So, because we want to hit the ground. So hitting the ground here, that's what's telling me that we're looking at zeros. So 0 equals want to solve this one by factoring? Yes, you could complete the square, but I don't really want to do that. That does not sound pleasant. Okay, so here I got two answers, but one doesn't make any sense because I get t is negative 1/5, and I also get t is 3. So this is t is 3 seconds when it hits the ground. Okay, and then this negative 1/5, that's telling me because we started at a height of 3 right here, this is at negative 1/5. So it goes on like that. Okay, but that's this going backwards. So in a sentence, it's going down at 3 seconds, or after 3 seconds has passed. All right. A soccer player kicks a ball with an initial velocity of 32 feet per second from a starting height of 0 feet. Using the vertical model, a motion model, okay, negative 16 t squared. This is the one for in feet, okay. Vt, initial velocity, so the initial velocity is 32, so this will be 32t. And then the initial height is 0. Calculate how long the ball will be in the air. Negative 16t squared plus 32t is equal to 0. And I'm going to factor it. So then t is equal to 0 or t is equal to 2. The ball is in the air for 2 seconds. Okay. One more. One leg of a right triangle is 3 feet longer than the other leg. We'll call this one x, and we'll call this one x plus 3. The hypotenuse is 15 feet. Find the dimensions of the triangle. Hey, write expressions for each side, and then plug into the Pythagorean theorem. Alright, so 3 feet longer, that's why I wrote x plus 3. And now I'm going to say x squared plus the quantity x plus 3 squared is equal to 15 squared. X squared plus x squared plus 6x plus 9, don't be foiled by that middle term. And then 15 squared is 225. Get everything onto one side. Minus 216. Just subtracting that on both sides. I'm going to divide everything by 2. I could also factor it out, but because I have an equation where I am equal to something on the other side, that's why it's okay to divide it like that. If you were uncomfortable that I did that, you could also factor it. That's fine. You could, if you wanted to complete the square on this, you could. Only really because you're got that coming up on our assessment. All right. So what do I want here? So we want to think about what multiplies to 108. 1 and 108 is not going to be helpful, but 108, 4 and 27, 6 and 18, 9 and 12. I don't know why I skipped 2 and 54. I guess because 2 and 54 doesn't make sense. Alright, so 9 and 12. Good. Plus 12 and minus 9. So this is going to be x is 9, or x is equal to negative 12. Well, that doesn't make any sense because length can't be negative. So x is 9. What do they want here? To find the dimensions of the triangle. So this is a 9, 12, 15 Pythagorean. So next you have your exit ticket, your exit quiz. So go ahead and complete that for me. Thank you.